Okay, in 9.1 we're going to look at the graphing method of solving systems of linear equations. Um, your note packet looks like this. The first thing we have to do when doing these problems in the Hawk system is it asks us to change the lines into slope-intercept form. If it didn't ask us to do that, we could probably put them into Desmos and take a look at them just in the form that they are. And remember, I'm just going to write Desmos here. Desmos is the graphing site, or desmos.com. So let's review how we change things into slope-intercept form. We could use this moving method, or it's kind of the addition method. I'm going to move the negative 7x over, and what's going to happen then is it's going to change signs as I move it to the other side of the equal sign, and I'm going to place that right after the equal sign, just so I can get it into slope-intercept form, and then I'll divide by 7 to get the coefficient in front of y equal to 1. So what I get here is I get y is equal to x minus 1. In the Hawk system, you're going to have these little boxes you're going to have to fill in. And so for the slope, I'm going to put 1. And then for the y-intercept, I'm going to put negative 1. Okay? And then quickly changing the other one, some of you might use this method where you write plus 3x and plus 3x. And that's just kind of similar to what I did on the first line. I get y is equal to 3x plus 11. Okay, and so I'll put that in to here. Okay. Now the Hawk system is kind of nice because it graphs the line for you. But if I had to do this longhand and my scale, this intercept's going to be a little bit off my grid here. But I'm going to graph this for you so you can see what it looks like. My starting point's at negative 1, so there's my starting point, and then my slope is rise 1, run 1, rise 1, run 1. So that's what line 1 looks like. I'm going to quickly draw line 1. Okay. Well, maybe quickly. There's line 1. And then line 2, the starting point's at 11, which is up here. I just kind of have to estimate where 11 is, and then I can't go up 3 over 1 because I'm off the graph there. So remember, if I have a slope of 3 over 1, instead of going up 3 and right 1, I could go down 1, 2, 3, and right 1. Now we're going to see kind of one of the problems with the graphing method is that if you don't graph absolutely precisely, you can't really tell where these intersect, okay? But in the introduction video for this module, I did show that if you graph it in Desmos, you can clearly see where the intersection takes place, okay? So looking at Desmos real quick and for a little review, if I type these equations in here, let's see, I have 1, y equals x minus 1. Oops, I got an equal sign there, I think. Minus 1. And then the second equation was y equals 3x plus 11. We see the intersection. Remember with Desmos, we can drag this and we can see the intersection is at negative 6, negative 7. Okay? So if we look here, I think if we count over negative 6, negative 7, that's the solution to that system of equations. Okay? So let's look at one more in this video. This equation right here, we could change. We already changed this one in number 1 to slope-intercept form, and it was y equals x minus 1. So it's just kind of a repeat of that first equation. And then looking at this one, we have add 6x, or we could use the moving technique. We get 6y equals 6x minus 6. And we get y is equal to x minus 1. Okay. So, well, if you take a look at this, we see that these two are an exact match. And so the lines are going to be on top of each other. Now we just need to know the vocabulary here, which case this is, and remember the cases of the lines, that which case it is here. Well, they're on top of each other because they're the same line. It's the dependent case, so there's infinite many solutions. Okay, infinitely many solutions. So we would select C. All right. So that's the first two in 9.1, and I'll make another video about the next two. Thanks.